Hi everyone, welcome back to assignment 2C part 2. I hope you have a good time working out the earlier parts of the question. For this segment, we'll be looking at part G. Determine the holding force due to the weight of chain in kilograms on the sea bed. So in part F, we've worked out the total footprint, and we're going to make use of this value, including the small x as well. Alright, let's look at what entails the holding force on the chain. Let's go to the diagram. Okay, so we have this diagram, the footprint and as well as the small x. So what does the holding force of the chain entail? It is basically the holding force due to the chain that is on the seabed that is contributing to the holding force. So whatever is on the seabed will contribute to the holding force of the chain. And this is worked out as a simple expression. So we have a holding force which is equals to the big X minus the small x. This gives us the distance of the chain on the seabed multiplied by the unit weight of the chain, and this gives us the holding force. Alternatively, it can be worked out as the total length of chain minus of the length of chain that is exposed to the seawater and multiply by the unit weight of the chain. So we're going to make use of either of this expression to work out the holding force in part G. Let's go back to part G. So in part G, what is the holding force due to the chain? So holding force is basically x minus small x multiplied by w. So in this case, we have 530.7 minus 483.2, and this is multiplied by 55, and I would have 2612.5 kilograms, and this is the answer that I have. Alright, happy trying, and I hope you get the holding force on your own. Okay, for the last part of the question, H, explain the impact on design based on the loads and geometry calculated in the above parts. So for this, this really depends on, if the load is too great, what happens to the geometry? Would there be any holding force for the matter? If let's say the force is not that great, then how would it be? The other part would be, how about the water depth of the environment? If the water depth is too deep, if the water is too deep, what would that mean? And would the length of the chain be able to provide that holding force for a deep water environment? So these are two conditions that you may want to think about, and how this impacts on the entire mooring chain. That's all I have. Have a good time trying out the questions. Thank you so much.